Hello everyone. So this is the first part of the video wherein we'll be seeing that how we can use Scikit-learn for supervised learning algorithms. So as we had discussed earlier, there are two types of supervised learning algorithms that we can define. One is regression and other is classification. So in this video, we'll be looking for regression, and in the coming forward videos, we'll be looking for classification. First of all, let us understand that what is regression analysis. Regression analysis is a predictive modeling technique that analyzes the relation between the target or dependent variable and independent variable in a dataset. The different types of regression analysis techniques get used when the target and independent variable show a linear or non-linear relationship between each other, and the target variable contains continuous values. The regression technique gets used mainly to determine the predicted strength, forecast trend, time series, and in case of cause and effect relation. Now the question comes, what are the different kinds of regression techniques? So the different kinds of regression techniques that we have are linear regression, logistic regression, ridge regression, lasso regression, polynomial regression, and Bayesian linear regression. In this video tutorial, we'll be learning about linear regression. Linear regression is one of the most basic types of regression in machine learning. The linear regression model consists of a predictor variable and a dependent variable related linearly to each other. So in case of the data that involves more than one independent variable, then the linear regression is called multiple linear regression, else it is called simple linear regression. So the equation for linear regression is y is equal to mx plus c plus e. So in the first part, which is mx, the m is the slope or coefficient, c is the intercept, and at times in the equation we even do add e, which represents the error. So to know more about linear regression and the theory behind it, please do check the video that has been mentioned in the link in the comment section. Now let us move forward to the coding part. In our code, we'll be importing different libraries such as NumPy so as to create the array and perform on it. Then we are calling linear regression from linear model. Then we are calling matplotlib for plotting, pandas for reading the CSV file. And as we had discussed in the earlier videos, we are using train test split so as to split the data into train set and test set. And in this video tutorial, we'll be learning a new trick, which is sklearn.metrics. So whatever we are performing, we need to know that how well are the model working with it, right? And so as to measure it, we use the metrics. And in this example, we'll be using R2 score and mean squared error. Let us go ahead and run these. First of all, we'll be taking the data of train CSV. Now let us just see that what this train CSV looks like. And it has X value and Y value. So as we see, we don't have multiple independent variable here. And that is why this is simple linear regression. Thereafter, we have to add the features and the target variables into X and Y. This is what we are doing here. And then we'll be splitting the data into train set and test set. Now, before moving forward with this step, let me just show you that if we don't use this function or scikit-learn, then how long will our code will be? So this is the code for the same. We have the same data. This is what we have plotted our data into. Thereafter, since we are not using scikit-learn over here, sklearn library over here, we have to split our data explicitly. And this cell and this cell does the same. Thereafter, we are assigning random values to theta as we need that for gradient descent. we are specifying the epochs value, the learning rate. Thereafter, this is the whole function that we are repeatedly calling and calling and calling, and we are learning the values which are of the coefficient and intercept, and we are even plotting the line simultaneously. So if you just see, first our model was plotting this. Thereafter, it learned the values of the intercept and the coefficient. And thereafter, it gives a proper line. And this is what the output looks like. So if we don't use the direct function, then there is this whole complex. If you don't understand this a lot, then it is complex, else this is the actual functionality that goes in the backend. So coming back, what we'll be doing is that we'll be calling linear regression and we'll be fitting our X-train and Y-train values. As we had passed here X-train and Y-train values for the same. Thereafter, we'll be learning the value of coefficient. So our value of coefficient is 0.996 and our value of intercept is minus 0.0672. Now, once I have learned my data under the seen data, I want my model to even learn the values of the data for the unseen data. How do I do this? Is by using the predict function, wherein we pass x test, and this predict function predicts that what will be the y prediction values, and these are the y predicted values. Now, just by seeing this, I cannot understand that are these the actual values that we wanted, or what is that? These are just numbers in front of me. And to solve this thing and to see that how well the model is performing, we use the metrics. The first we have mean squared error. So mean squared error is actually the average squared distance between the estimated values and actual values. Right, so we have the actual values and then we have the estimated values, and we find the average of the squares of differences, and the mean square error that we are getting here is 8.48. Then we have the R2 value. Now R squared value is a statistical measure of it that indicates how much variation of a dependent variable is explained by the independent variable in the regression model. So here our R2 score is 98.99%. Thereafter, we'll just plot it so as to see and enjoy the model that we have learned. And as we can see here, our line perfectly fits the data points. I end this video with a small trick. What if I don't want my Jupyter notebook to show me this output? Because it is not necessary for me to see it. For that, simply add a semicolon over here, and there you go. You won't see this. So that's all for today. Have a great day ahead.